Okay, good morning. Okay, today we are going to continue the heat equations. Del U del T equal to C squared del 2U del X2, where the X is positions from 0 to L and T is greater than 0. Okay, today we are going to look at the Crank-Nicolson implicit finite difference method after you have learned the explicit finite difference methods. Okay, for the Crank-Nicolson methods, the U is a function of X and T. Okay, and U is actually standing at the point. Okay, this is a horizontal is a X axis where the center is a I. So the ahead you have a I plus 1 where the delta X is a H. Okay, at the back you have the I minus 1. So this point is Uij, ui plus 1j, ui minus 1j, this at level j. Okay, for the Crank-Nicolson implicit finite difference method, u is approximate at the point xi tj plus half, okay, or we simplify as del u. Okay, so you see del u del t, so u at the point u, xi j t at the j plus half, so it's a c squared del 2u ij plus half, okay, del x squared. Okay, so this is a level j plus half, this is a level j, okay, j plus 1. And then for del u del t, because you're standing at the, this point is ui j, j plus half. Okay, hold on. And, the cross point, this is a point ui j plus half. So for the del u del t, okay, standing at the middle, so you use a 3-point centra, the point ahead, which is uij plus 1 minus, okay, this point is actually uij, okay, so is and then you have here 2 times of k over 2, okay, that's why what we obtain is actually, okay, for del u del t at the point xij plus half, after using 3-point centra, okay, you obtain, okay, exactly this one here, uij plus 1 minus uij divided by k is actually, okay, you have here k over 2 plus k over 2, 2 times k over 2, that's why you get k here. You obtain the k here. And then k for second derivative of, okay, uij plus half here, this point uij plus half, okay, so this is a level j plus half, okay, is average, okay, by level j and level j plus 1, okay, that's why you have, okay, initially is c squared, mean you have actually is del u del t equal to c squared del 2u, okay, del x squared, u at the point I j plus half, okay, u at the point I j plus half. So j plus half, okay, is actually we average level j and level j plus 1. So this is actually the level j plus 1. Okay, this is a level, okay, j. Mean this is actually average, okay. This point is actually ui j plus 1. Mean this is actually the del 2u ij plus 1 del x2. The second term is actually del 2u I j divide del x squared. So mean, okay, to find the second derivative at the point uij plus half, okay, at the point j plus half will be, okay, left point 1 time, okay, the center point minus 2 time plus, okay, right point ui plus 1 j plus 1 divided by h squared. Okay, the second term here is actually the, okay, del 2u, okay, del x2 at the point uij, so you have ui minus 1j minus 2uij, okay, plus ui plus 1j divided by h squared. So, okay, we average it, then we can get the second derivative at the point uij plus half here. Okay, and the time derivative is actually look like you do the 2-point forward for the explicit method. Because explicit method, okay, we are standing at the uij. Take the point ahead, uij plus 1 divided by uij. Okay, here from uij plus 1 to uij is actually delta t is k. You are standing at uij plus half. This is ko2, ko2. And the approximation here is actually 3-point centra, but the result is same. So, but okay, the idea is actually from 3-point centra at the point uij plus half. Okay, after that, okay, we cross, okay, multiplication. So you have 2 uij plus 1 minus uij equal to, okay, where the kc squared over h squared is r. So you have r time, okay, ui minus 1 j plus 1 minus 2, okay, mean all here, k, you have kc squared over h squared time, okay, this term, rui minus 1 j plus 1 minus 2 uij plus 1 plus ui plus 1 j plus 1. Okay, and then all this, the last three term here, ui minus 1 j minus 2 uij plus ui plus 1 j, where the r is actually kc squared over h squared, okay, same with the explicit method. Okay, and then we're collecting all the level j plus 1, to right hand side, left hand side. So you have, okay, become minus r, ui minus 1 j plus 1. This will become plus 2r here. Okay, plus 2r, collecting with here 2. So total is 2 plus 2r ui j plus 1. Then this term, okay, plus r, bring to left side, become minus r ui plus 1 j plus 1. Okay, and the last three term here at the still maintained at right hand side. So you have r, okay, r ui minus 1 j. So this is minus 2r. Okay, collect with minus 2 uij. Bring to right side, become positive 2. So this is minus 2r uij. So this is a r ui plus 1 j. Okay, and then from here, if you put up to molecule, mean ui minus 1 j plus 1, this is actually mean the coefficient here, this is minus r, okay, 2 plus 2r uij plus 1. So this is minus r, okay, at the, okay, level j left bottom, you have this is positive r. Okay, this is 2 minus 2r, this is positive r. From here, you can put to the molecule, which is, okay, helpful, like here. Negative r ui minus 1 j plus 1, 2 plus 2r ui j plus 1. So minus r ui plus 1 j plus 1, this at the targeted top level, okay, equal to r time of ui minus 1 j, okay, and then, okay, 2 minus 2r time uij, and then r time of ui plus 1 j, okay, where the ui minus 1 j, uij, ui plus 1 j is a left bottom, center bottom, right bottom, where we can denote in the calculator as a b, c. Okay, and then the example 3, because it continuous from the explicit scheme. Okay, given the heat equation del u del t, okay, del u del t equal to 4 del 2u del x squared, where the x from 0 to 2, t is positive, with the boundary condition u0t equal to t exponent negative t u1t equal to t. And the initial condition given ux0 is actually x when x from 0 to 1. When x from 1 to 2, the function is 2 minus x. Find ux 0.01 using implicit finite difference method for x from 0.5 to x equal to 1.5 with h equal to delta x equal to 0.5. Okay, first step, okay, draw the grids. Okay, we have the grids x from 0, 0.51, 1.52. Okay, t, we solve it, okay, from 0.0 up to 0.01, 0.02. And then put up the, okay, this is a boundary condition. Okay, boundary condition, hold on. Put up the calculator. Okay, so, okay, first of all, we put out the, okay, boundary condition u0t. So mean x0. Okay, the function is t exponent negative t. Okay, easy, we use the, okay, table menu. t exponent negative t. So in the table menu, you have to change t to x. So it's a x exponent negative x. Gx, gx maybe gx, we put this one, 2 minus x. Because you can put it two function. No, different intervals. So I put 0. Okay, starting this one 0. Okay, ending 0.02. Step side 0.01. Okay. So when t0 you get 0, t1 at 0.01 you get 0.0099, t 0.02 you get 0.0196. So this is a left boundary. Right boundary, when sorry, this one should be 2. Okay, typo. u2t equal to t. u2t equal to t. Okay, later on, initial condition, when x 0 to 1 equal to x. So that's why equal to x. x0 is 0, x 0.5, this is 0.5, x1 is 1. X from 1 to 2, the function is 2 minus x. So 2 minus 1, you get 1. 2 minus 0.5, you get 0.5. 2 minus 2, you get 0. So the yellow color, okay, this left, this is the initial condition, this is the right boundary condition. So you need to find u11, okay, u11, u21, u31, u12, u22, u32, because I, okay, I exactly, this is a u I j I, this is 0 1 2 3 4, and then j here 0 1 2. That's why u11, u21, u31, u12, u22, u32. So you got 6 unknown to be solved. Okay, and then we have two ways. Okay, you can either using the molecule we have here, negative r. This is 2 plus 2r. This negative r. This is r. This is 2 minus 2r. This is r. So this you can calculate r. Okay, what's the r value? Okay, you can calculate. Actually, r is kc squared over h squared. Okay, k is 0.01, h squared. Okay, h squared from the coefficient of okay del 2u del x squared, h squared is actually 4. So times 4 divide by h, which is 0.5 squared. Okay, you can calculate here. So k 0.01 times 4 divide 0.5 squared. Get 0.16. That's why here. So r is 0.16 here. So this is negative r, positive r, positive r. Then you can find 2 minus 2r, 2 plus 2r. So 2 minus 2 times answer. So 2 minus 2r, you have 1.68. 2 minus 2r, 1.68. Okay, and then calculate 2 plus 2r. Because the answer is wrong. Answer the latest is no longer 0.16. Okay, so I have to 2 plus 2 times 0.16, because answer keep the latest. So 2.32. 2 plus 2r, you get 2, okay, 2.32. Okay, let's see back. The general molecule, negative r, 2 plus 2r, negative r, r, 2 minus 2r, r. So first step, you draw the grid, put in, discretize the x, t, okay, put up your left boundary, right boundary, initial condition, then calculate the r, calculate 2 minus 2r, calculate 2 plus 2r, then you get the specific K molecule for the Crank-Nicolson implicit scheme for solving heat equation. So okay, you can use this molecule, or okay, the right hand side, this one is the difference is okay, we make it mean we minus we divide by r, so that's why here you get -1, -1 is +1, +1, so mean this one is 2.32 divided by r, which is 0.16. When you have here 2 point 2.32 divide 0.16, have here 14.5. Okay, this value 1.68 divide 0.16, 10.5. So it's either you want to use this one or divide by r at each cell there. Okay, then because the the result provided using this one. Okay, if you use this one or this one, of course your system of linear equation is different, but the result must be same. Okay, after that we apply the molecule. In this case we use this one because okay easier, number is 1 there. So we apply the molecule, then you have like this molecule equal to here. Okay, so mean you have okay that's why you get, you see, -1 times this value, so -0.0099, okay, plus 14.5 U11. Okay, mean they take the coefficient in the molecule times the value in the grids here. So -1 times 0.0099 plus 14.5 U11 minus U21. Okay, and then it's actually how I get 6.25. Okay, this 6.25 is actually okay 6.25 is okay 1 times 0 plus 10 times 5 times 0.5 plus 1 times 1. You get the result here, 6.25. Okay, I'll show to you. Mean you have okay 1 time, so mean is 1 times 0, mean you have 1 times 0 plus 10 times 5 times 0.5 plus 1 times 1. You get 6.25 here. Okay, 6.25. Or I can put out here 1 times A, 10.5 times B, 1 times C, where the ABC is here. Because later on, okay, when you first time, okay, this is center top, you target at U11. So you have here. Okay, later on, move your molecule one column to the right, one column to the right. Then you see the pattern is actually repeated. Okay, when I move, okay, one column to the right, okay, the center top will be at U21. Okay. So now second equation, okay, center top, okay, second equation center top at here. So you have 1 time, -1 U11 plus 14.5 U21 minus K U31, -1 time U31 equal to okay 1 time 0.5 plus 10.5 times 1 plus 1 K times 0.5. So you get this value. You see, okay, 1 time. Okay, this value, okay, is actually the A, B, C value, which is changed. Coefficient here is constant. Only the value at the okay left bottom, which is A, center bottom, which is B, right bottom C, only A, B, C here change. So must well you put up to calculator. Okay, you can put alpha A plus 10.5 alpha B plus, okay, this is 1 time C, where A, B, C are left bottom, center bottom, right bottom from your center top targeted okay, cell there. Then you calculate. So A is 0.5, B is 1, C is 0.5. So you get 11.5 here. Okay. And then later on, move one column, okay, to the right. Okay. So we'll target at U31. U31. Okay. I want to erase first. Okay. Later on, move one column to the right. So you're here. So here. So minus U21. Okay. This is okay plus 14.5 U31. Then got typo. 14.5 U31. Why minus? Okay, and then minus 0.01. Because this value, okay, is a right boundary equal to, okay, 1 time, okay, 1 times 1 plus 10.5 times 0.5 plus 1 times 0. Okay, or we already key in into the calculator. Okay, 1 times A is the left bottom, B is the center bottom, C is the right bottom. So you calculate A is 1, B is 0.5, C is 0. So you get 6.25. Okay, then later on, this value, negative 0.009, you collect to right hand side. This value collect to right hand side. Solving these three linear system together, then you can solve U11, U21, U31. Okay, let's see the next slide. That's what we obtain here. Okay, then from here, 14.5 U11 minus U21. Okay, these two values you collect together. Okay, mean you have 6.25 plus 0.0099, 6.2599. So you see, okay, these two to collect together, you have 6.2599. Mean coefficient for U11 14.5, coefficient for U21, so is negative 1. So 14.5 negative 1, you don't have a U31, so it's 6.2599. Okay, and then second equation is actually, okay, coefficient for U11, U21, U31 is negative 1, 14.5, and negative 1, 11.5. Yeah, negative 1, 14.5, negative 1, okay, 11.5. Okay, and then the third equation, sorry, the third equation, negative U21, 14.5, U31. So negative 1, 14.5 U31. Okay, how I get 6.26? Exactly 6.25. You add up 0.01, so you get 6.26. Yeah, 6.26. Okay, and then using your scientific calculator, you can quickly obtain U11, U21, U31. Then you put up here. Okay, and using your scientific calculator in equation modes. Okay, simultaneous. So 3. So key in the coefficients. Yeah, 14.5, negative 1, 0, 6.2599. Okay, and then negative 1, 14.5, negative 1, 11.5, 0, negative 1, 14.5, 6.26. So you get the x, which is a U11, 0.4911, y, which is a U21, 0.8608, z, which is U31, 0.4911. Okay, so you put up the value here, U11, U21, U31. And the process is repeated. Okay, repeated. Okay, apply the molecule. Then like this. Okay, you apply the molecule. Okay, now this is a center top. Here, here, here. Okay, you get first equation. Move, okay, to here where this is a center top, you get second. Move where this is a center top, you got third equation. Okay, and the process is repeated. Then you can solve for your U12, U22, U32, like here. Here. When the process repeat again. Okay, so when we repeat again here, first time this value is negative, because negative 1 times 0.0196, this value, okay, times 14.5, U12, okay, this is negative, equal to, okay, so this value 1 times this value plus, okay, 10.5 times this value plus 1 times this value. You get here. Okay, so search back, okay, the formula just now. Oh, missing. So you have alpha A plus 10.5 alpha B plus alpha C. Calculate. A is left bottom 0.0099. Okay, B is 0.4911. C is 0.8608. So you get here 6.0273 here, 6.0273. Okay, and then okay, move, okay, the molecule one column to right. So this one erase. Okay, here. You get the second equation. So this is negative U12 plus 14.5 U22 minus U32 equal to, okay, A, okay, 1 time A is here, 10.5 times B is this value, 1 times C is 0.4911. Then you get 10.0206. Okay, you calculate. Now A is 0.4911, B is 0.8608, C is 0.4911. So you get here 10.0206. Okay, and move one column to the right to get the third equation. Okay, so you're moving here. Okay, you're moving here. The third one. So negative U22 plus 14.5. This one also typo. Plus 14.5 U32. Okay, plus, minus, because here minus 0.02 equal to, okay, 1 time here plus 10.5 times this value plus 1 time this value, you get, okay, 6.0274. You can see here. You calculate again. A now is 0.8608. B is 0.4911. C is 0.01. So you get 6.0274. Okay. And then this value, you have to collect because it's a boundary condition. This is a left boundary condition. You collect together to right hand side here. Okay, and you will notice, okay, actually the matrix A that you obtain is actually, okay, follow this pattern. This one, -1, okay, 14.5, -1. This will give you, okay, mean the top, the targeted top level will give you the coefficient for your matrix A, and it is actually 3 diagonal. When you have, this is U11, U12, or U level 2, U22, U32. Okay, second level, okay, this one is 10.0206. This is -1, 14.5. This is -1. Okay, this is -1, 14.5. This one 0, 0. Sorry, 14.5. Sorry. Okay, the first equation you have 14.5 U12. In here, 14.5 U12. So -1, 0. When you see here, it's 3 diagonal and the coefficient is actually followed. Okay, the coefficient for the targeted top level -1, 14.5, -1. So 3 unknown. U12, U22, U32 is a vector V. Right hand side. Okay, the first and the last equation, make sure take care of your left boundary and the right boundary. Okay, so the first, okay, the vector B, you have here 6.0273. Okay, you need to add up minus. So bring to the other side plus 0.0196. So you get 6.0469. So mean you have 6.0469. Okay, the last equation you add up with 0.02. So total is 6.0276. Okay, that's what you obtain here. I think got some mistake. Add up with 2. 6.0276. This one should be 76. 6.0469. Okay, this is 6.0274. Add up with 0.02, 6.0276. 76. Okay, we check the value here. And then, okay, using the equation mode, you can obtain the U12, U22, U32. Okay, typo. So we go to the menu here, equations, simultaneous equation, 3 equation. Okay, you have 14.5, -1, then 0, 6.0469. Okay, the second equation, -1, 14.5, -1, 10.00206, then 0, -1, 14.5, then 6.0476. So 0.4692, 0.7558, 0.4692. Okay, this one typo, but the solution correct. Then put up, okay, into the grids you have here. U12 0.4692, U22 0.7558, okay, U32 0.4692. Okay, this is solving manually using your scientific calculator. Okay, and then if you're interested to solve it using Microsoft Excel, okay, later on, okay, to solve it using Microsoft Excel, so we have the del U del